Hi everyone. So today we're going to discuss how to simplify radicals. There are two methods that you can go about this. The one that we really need to know, which I feel like is something you'll need to know for future math classes, is the perfect square method. So the first thing we need to know is what are our perfect squares? A perfect square is a number created when you multiply the same number times itself. For instance, 1 times 1 is 1, 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49, etc. There's an infinite number of them, but the only ones you really need to know are all the way up to 144, which is 12 times 12. So we need to find out, when we're given a square root, which of these perfect squares can divide evenly into that radical. In this case, we have the square root of 50. So looking at this list over here on the left-hand side, which of those values divides into 50? Is a factor of 50. And in this case, 25 really stands out because 25 times 2 is 50. So let's write it as the product of two radicals, square root of 25 times square root of 2. Because 25 times 2 is 50. Now that we have a perfect square, we can take the square root of any perfect square. The square root of 25 is 5. We cannot take the square root of 2 because it is not one of the perfect squares, so it will remain a radical. And we have finished simplifying. The one thing that you need to remember with simplifying radicals, though, is that you want to find the biggest perfect square that can divide into them. For instance, let's look at the one over here on the right, the square root of 96. So we're going to try using the factor tree method, but first let's look at how we would do it using the perfect square method. I'm going to do it over here on the side. Now, looking at 96, it's a large number, so it might be hard to decide which of these perfect squares goes into 96. So I would start with the bigger numbers because I actually know that 4 divides into 96. But 16 also does. If I use 4, I will have to factor more than once, or I will have to simplify more than once. And I don't want to have to do that. So I'm going to choose 16 instead. So 96 is 16 times 6. And I can find the square root of 16, which is 4. If I had chosen the smaller perfect square that divides into 96, I would have had to simplify twice. And I don't want to do more work. I don't know about you. Now, the other method that we can use for this is called the factor tree method. And it's where we're going to use all the things we know about what multiplies to give us 96 and create all the factors that multiply to give us 96. If you're not sure what factors go into 96, start out by looking to see if it's an even number. If it's an even number, then 2 will go into 96. 2 times 48. Okay? So from here, 2 is a prime number. There's nothing that multiplies to give us 2, but 48 is 2 times 24. And 24 is also an even number. So 2 times 12. 12 is also an even number, 2 times 6. And 6, lastly, is 2 times 3. Now, what do I do with all these numbers? The only numbers we're going to use are the numbers at the ends of the branches, okay? That's these ones here. I'm not going to use any of these other numbers. So basically, I'm only using the prime numbers, okay? I need to circle any pairs that I have. So for instance, right here, I have a pair of 2s. Here I have a pair of 2s. And then I have an extra 2 and an extra 3. So here's how I'm going to write my final answer. Okay. Over here, when I have a pair of 2s, what we need to decide is what goes in the square root and what goes on the outside of the square root. Okay. I usually like to think of it as we have a couple of 2s, so they're not going to be inside the house, is what we'll call it, because they're going out on a date. Whereas this 2 and this 3 down here at the bottom, they don't have a date, so they're stuck at home inside the house. So let's see what we do. With the pairs, I'm going to mark one out and the other one goes outside the radical. Same thing with the other pair. I'm going to mark one out and put the other one on side of the radical. And those two numbers will get multiplied. The two numbers that do not have a pair, remember we said they're staying at home, okay? So the 2 will stay home and the 3 will stay home because they do not have a date. Okay? Now we just multiply. The 2's on the outside of the radical get multiplied, and the 2 and the 3 on the inside of the radical also get multiplied to create 4 radical 6. Now there is one last thing that I would like to look at, and that is what happens if there's a number already in front of the radical. What would we do? Okay, so I'm going to scroll and try one more example with you. Okay, let's say it is 3 radical 98. Okay. So the first thing we're going to do is I always want to remember that that 3 is already in front of the radical. Okay, so I'm going to bring it over here so I don't forget about it. Now I'm going to make my factor tree with the 98 because it's kind of a big number. I don't know what perfect square goes into 98. Okay, so 98 is an even number, so 2 will go into it. 98 divided by 2 is 49. I know 49. 49 is a perfect square. 7 times 7. So these are the only 3 numbers I've got because they're all prime numbers. I can't continue the factor tree anymore. So I'm going to circle some pairs. And let's remember what we said. If they have a date, that would be the ones I circled. You mark one out and the other goes on the outside. So see, that 7 is going to get multiplied with the 3 from the original expression. Now this 2 here, he doesn't have a date, so he is going to stay at home in the house. Now all that's left is to multiply 7 times 3 and we get 21. If you need any other help with radicals, if you're in my class, just make sure to come into tutoring. If you're not, you can leave a comment in the chat and I can try and help you out. Okay? Have a great day.